Hello and welcome to today's video. In today's video, I'm going to explain to you the concept of finding where two graphs intersect with one another when we draw them on the coordinate plane or the Cartesian plane. So over here I'm using Desmos.com. It's an excellent graphing website. If you want to draw graphs on it, it's completely free. You can create an account on it. Use this website, it's completely useful. So I have this graph here, y is equal to 2x squared minus 4x, which is this parabola here. It's quadratic because of the x squared term. And then I have the straight line y is equal to x. Y is equal to x. Now from here you can see that these two graphs, they intersect each other, or they cut each other, or they meet each other at these 2 points, 2.5, 2.5 and 0, 0. This is where these two graphs meet. This is where these two graphs intersect. Now in the exam, you're not going to be given these graphs like this, so you're not going to know where they intersect. But you can be given a question where you are asked to calculate, not by scale drawing or anything, but to calculate mathematically to find where these two graphs intersect each other, where these two graphs meet each other, where these two graphs cut each other. Obviously here I'm using Desmos, so I can simply plug in the equations and Desmos will tell me where these two graphs intersect. But let's say I was just given the graph, I was just given the equation. Let's say a question says you have the graph y is equal to 2x squared minus 4x and the graph y is equal to x. Calculate where these two graphs intersect, where these two graphs meet. So you can't draw these things, you can't use Desmos with you in the exam, but you need to calculate where these two things meet. So in this video, I'm not going to go into the calculations of it, but I'm going to explain the basic idea, the basic concept of how to do that, and then in the next videos we actually start calculating. Well, what do you notice about these two graphs here when they cut each other? Where they intersect each other, the y-coordinate of both graphs is the same. Okay, the y-coordinate is the same. If you go to this point on the graph, the y on the blue graph here, if I go to the blue graph here, the y-coordinate on that blue graph at this point is 2, 5. But if I go to the red graph as well, the y-coordinate is also 2, 5. Same applies here, the y-coordinates are the same. So you can see here that wherever two graphs meet each other, those points where the graphs meet each other, those points where the graphs intersect each other, the y-coordinate of those points on both graphs is the same. So if this y here is equal to this y, remember, we have y is equal to 2x squared minus 4x. We have y is equal to 2x squared minus 4x. And we have y is equal to x. Okay? If these two y's, because remember, this y gives us the y-coordinate. Y gives us the y-coordinate. So if the y-coordinates are the same, and the y-coordinates are 2x squared minus 4x and x, then it makes sense for us to equate the y-coordinates, because if the y-coordinates are the same, if they are equal, then we equate these two and say 2x squared minus 4x is equal to x. Okay, because this gives us the y-coordinates on the parabola, and this gives us the y-coordinates on the straight line. This x here, it gives us the y-coordinates on the straight line. This 2x squared minus 4x here, it gives us the y-coordinates on the parabola. So if the y-coordinates are the same, we are looking for points whereby this 2x squared minus 4x is identical to this here, to this x here. So we would equate the two. And if we equate the two, we have an equation. And the solution to that equation is going to give us the x coordinates now. The x coordinates, it will give us this 2.5, which is the x coordinate. It will give us that 0, which is the x coordinate. This was x plus 2. Okay? Let's say this was, let's change the graphs. Let's change the graphs. Minus 2. Okay? So now I have x squared minus 2, and now I have x plus 2. So they intersected this point here, and they intersected this point here. Again, the y-coordinate of the blue graph here is equal to the y-coordinate of the red graph. Same applies here. Okay? Same applies here. So we have y is equal to x squared minus 2, and we have y is equal to x minus 3. Okay? Oh, sorry, x plus 2. X plus 2. X plus 2. X plus 2. Okay? So we have y is equal to x squared minus 2, and y is equal to x plus 2. So again, where those two graphs cut each other, where they intersect, the y-coordinate of this red graph is equal to the y-coordinate of the blue graph. So we equate the two y-coordinates because they are the same. We equate them. In maths, if you say a is equal to b, it means a and b are equal. They're the same. Okay? So we would say x squared minus 2 is equal to x plus 2. And now we have an equation here, and the solution to this equation here, it will then give us these x coordinates here, the negative 1.562 and the 2.562. The solution to this equation here would then give us the x coordinates to where they intersect. Okay, to where they intersect. Let's look at this one. These graphs, they only intersected one point. They don't intersect at more than one point. But the same concept applies. The y-coordinates are the same. The y-coordinates are the same. So we have x plus 2 and we have negative 4x plus 2. Okay? X plus 2 and negative 4x plus 2. So we have y is equal to x plus 2 and we have y is equal to negative 4x plus 2. Okay? Negative 4x plus 2. So, at the point where they intersect, the y-coordinate is the same. The y-coordinate is the same. So if this gives us the y-coordinate of one line and this gives us the y-coordinate of the other line, if the y-coordinates are the same, then I simply equate them because they're the same, isn't it? If they're the same, I can equate them. And the solution to this equation here will therefore give me this x-coordinate here where the lines intersect. So that's why whenever we want to find where two graphs are intersecting, we equate the equations. We equate the equations. The equation of this line, we equate it to the equation of this line. So what you'll notice is that this equation here, it's a quadratic equation, so we're going to have two solutions. We're going to have two solutions to this. Which makes sense because when we drew our graphs earlier, we saw that the graphs were cutting each other at 2 points. The logic is, if this equation gives us the points where those two graphs meet, if those two graphs are meeting at 2 points, then this equation should give us two answers. Okay? And it does give us two answers. It's a quadratic. Same applies here. These two graphs were meeting at 2 points. So if this equation here gives us those points, and there are two, this equation should have two answers, which makes sense. It's a quadratic. If this equation here gives us the coordinates where these two lines meet, these two lines are only meeting at 1 point, so this equation here must only have one answer. That's the logic behind the matter. So until next time, thank you.